Welcome back. This is College Algebra Videos. Today we'll be talking about the change-based formula. And in fact, we're going to evaluate certain algorithms where we can't use our calculator at the beginning, but eventually, because we know the change-based formula, or at least how to get it, we'll be able to find these logarithms. So instead of actually showing you the formula, I'd like to show you the technique, because the technique that we use to find this formula is very useful and in solving other types of problems. So let's go ahead and get started. First of all, I want to remind you this. You have this already. I think this is in many videos. But we do need to know how to translate. And the key to today is to be able to translate something that looks like this into an exponential function. Okay. The other thing I want to remind you is that, well, you'll see it. You'll see it when we do the problem. So let me do it there. Okay. So let's go ahead and get started. So in today's homework, you'll actually have to find what these are. So the goal is to find out what this is equal to. Okay. That's what we'd like to know. And they want you to use the change of base formula in base 10. I'll explain what that means in a minute. Then they want two answers, one in exact form and one that's an approximation. So how do we get to do this? Well, I don't know what this number is, so let me call it y. Let me call this number y. Okay, I don't know what that number is, but let me call it y. So one of the first things I'm going to do is translate this into an exponential equation. Remember that the 7 is the base, the y is the power, and the 60 is our answer. So when we find out what y is, one way to think about it is we're finding what power of 7 gives me 60. Now I want you to think before we even do anything else. Think about it like this. We know that 7 to the first power is 7. We know that 7 to the second power is 49. And we know 7 cubed, well, that's a pretty large number. I believe it's 343. You might want to double check that. So somehow our answer, if you notice, we want it to be 60, so it has to be a number between 2 and 3. And so hopefully after our work we find out that it is a number between 2 and 3. So how do we approach this? Well, in the last video, or in the last homework 6.13, we learned that one of the things that we can do is we take logs of both sides. And so here's where the base 10 comes in. So the book says use log base 10. Well, that means is take the log of both sides, but make it the base 10 one. So remember that taking the log just means we have this function log, and we're going to put inside of it these two numbers that are equal to each other. And one of the nice things about this is that you recall that there's a property that says that when you have a power on something that's inside of the log function, that power can come up to the front. And so we're left with y times log of 7 is equal to log of 10. Well, okay, what does that do for us? Well, check this out. Okay, we want to solve for y. That is our goal. Our goal, if you remember, is to solve for y right here. I want to know what this number is. So when I divide both sides by log of 7, I get that y equals log of 10 over log of 7. Okay, so that's what it is. But how is this helpful? Well, the thing is that this expression on the right-hand side, you can plug into your calculator quite easily. And in fact, I'd say maybe pause the video and go ahead and plug it in right now. What you should have gotten after you plugged it in is the following. We get that y is approximately 2.0104. And so here's my exact form, and here is my approximation. All right, so on the homework, we want you to do both. And in fact, they're going to give you a choice as to whether you want it in logs or natural logs. And so in this first example, we'll do logs, the common logs. And the next example, I'll do natural log. All right, so let's go ahead and try the second one. So we do the same thing. We say, let's set this equal to y. We don't know what that number is. And then let's go ahead and translate. Remember that 3 is the base. 3 is the base. And so we write the base to the power, which is y, is equal to 1.73. Now let's say if this, before we go any further, We know that 3 to the 0 is 1, and we know 3 to the first is 3. So we're expecting our answer to be between 0 and 1. Okay, our answer y should be between 0 and 1. So here we take the log of both sides. So that means is that I have the log function. I'm going to put something inside of that one, and I'm going to put something inside of this one. And it's going to be the same number except different ways of writing it. On the left, I'm going to put 3 to the y. On the right, I'm going to put 1.73. I remember that this exponent can drop down to the front. So I'll get that y times log of 3 is equal to log of 1.73. All right, well that means now I can divide both sides by log of 3. And when I divide both sides by log of 3, I get that y is equal to log of 1.73 divided by log of 3. And so that would be my exact answer. But if I want an approximation, then I plug that into my nice little calculator and I get 0.4989, which makes a lot of sense because that's exactly what we expected up here, a number between 0 and 1. That one definitely is between 0 and 1. Okay, so we're going to try the same thing, except now we're going to use a different base. So, an example, we're going to evaluate, and this time they want us to use base e. And so what that means is that when we take that step where we take the log of both sides, instead of taking the log, we're going to take the natural log. So, but let's go ahead and do an example. So, let's do this first one. Let's set this equal to y. Now let's translate. The base is 5. The power is y. The answer is 152. Again, I'm going to take a little bit of a break here, just to remind you guys that 5 to the first is 5. 5 squared is 25. 5 cubed is 125. And I believe you might want to check, but I think 5 to the fourth is 625. So I'm expecting an answer between 3 and 4. Okay, so this helps me. This step is not necessary, but it helps me know that I got my answer correct. All right, so now, this time instead of taking the log of both sides, because they want base e, we're going to take the natural log of both sides. Again, this means that we're using this function, the natural log, and an input. On the left, the input would be 5 to the y, and on the right, the input is 152. But then we remember that when we have an exponent, it comes to the front. So I have y times natural log of 5 is equal to the natural log of 152. All right, what does that mean? Well, now it means I can divide by the natural log of 5. So let's divide by the natural log of 5 here. Let's divide by the natural log of 5 here. And I get that y is equal to the natural log of 152 over the natural log of 5. So this is my exact answer. And then my approximation answer, we plug this into the calculator, and the calculator says 3.1215. And that's my second answer. Okay. All right, let's do this last one. We set this equal to y. And again, this means that we have 0.5y, 0.5, the base, to the y power is 0.125. Again, I take the natural log of both sides. That means I have this function, natural log, and its input on the left is 0.5y. The input on the right is 0.125. The exponent is the y. It comes out to the front. So I have y equals, or y times, natural log of 0.5 is equal to the natural log of 0.125. I solve for y. So let's divide both sides by the natural log of 0.5. And so I get that y equals natural log of 0.125 is equal to the natural log of 0.5. I plug this into my calculator, and the weirdest thing happens is that it's actually equal to 3. And in fact, in this specific problem, the best answer should just be 3. But why is it 3? How did it come out to 3? Well, notice I didn't do my usual. I don't know what 0.5y is to any power, and I actually skipped it on purpose because I wanted you to maybe think, okay, how come you didn't do that? Well, let me explore a little bit. You guys know that You guys know that 0.5. So here we're gonna look at this guy, at this side. You guys know that 0.5 is the same thing as 1/2. And 1/2 to the first power is 1/2, which is 0.5. 1/2 to the second power is 1/4, which is 0.25. And 1/2 to the third power is 1/8. And this is 0.125. That's why the answer was 3. And so if I would have known my powers of halves, then I would have been fine, but I didn't. But this is one of those where sometimes if you know a little bit more, you can get the answer quicker. All right, we'll stop here. This should help you with your homework. If you have any questions, please don't hesitate to ask.